Okay, so lesson 5. This is the beginning of a series of lessons that look at the landscapes, landforms, processes that are created at the plate margins. So I've done this not quite in the order of the spec. It starts with destructive, I start with constructive. So there's a whole bunch of these that we'll look at, and I'll show you in the next slide. So margin is like another word for margin is boundary. There's a couple of double up words that are used within the whole range of these. So let's not delay and have a look. Okay, so previous lesson, I went through the key processes that are moving the plates. So everything from the convection cell, convection currents there, seafloor spreading, and then ridge push and slab pull. These are important for you to do, and some aspects of it you may include in the explanation of the margins, the plate margins, plate boundaries that you get. So if we look here, so GCSE, you're taught usually three plate boundaries: destructive, constructive, conservative. Each of these has subdivisions. That's certainly something at A level that you have to know. And also, if you look down here, this relates to hotspot theory. Some of you may have done that. And then you can see, look, the process, these are action words that create the margins, but also the landforms that go with it. You can see we've got seismicity, that's basically code word for volcanoes, what I'm talking about, earthquakes, and volcanicity, I think that speaks for itself, volcanoes. And you can see this range of landforms here. Now, each of these can be posed as a 4-mark question. In fact, 2024, they asked for the explanation of an ocean ridge. It could be a fold mountain, it could be an island arc, etc. It's important to know the distinction, and some of them are down to the sub-variations. A couple of words that we sometimes use instead of constructive, you'll see on the next slide. Sometimes you use the word convergent and divergent. That's just a description of the movement. Today, I'll be talking to you about constructive margins, known as divergent margins. There are 2 of these. So here we go. You can see the word divergence, divide, move apart. The word construct is what it means. It means that new plate, new crust is formed. So you've seen a little bit when I was in the previous lesson when I was talking about the ocean ridge, ridge push theory, etc. The one that's pretty much always taught lower down the years is ocean to ocean divergence. So this is a constructive margin. You get a ridge, ocean ridge formed, probably the more straightforward of the two, but you do need to know about continental to continental. This is where 2 continental plates, or the continental plate, is splitting. Okay, so there are some similar processes, but also some distinct differences, hence the word rift valley. Okay, so in this lesson, I will go through both of those. So just illustrating the image that you get here. So if I were to draw an arrow or 2 arrows, that plate is one side there, and I'd have an arrow moving that way, and that's moving that way. And if you remember from the previous video, we have a ridge, and this is, I suppose, the top of the ocean, obviously not to scale, and this extends some way. This type of margin, and the most famous of this is the Mid-Atlantic Ridge, is incredible in size, stretches almost up to the Arctic and down to the Southern Ocean. It's 60,000 square kilometers, and there's a whole range of features that are there. So new crust is being formed. Well, not technically, actually. The crust is younger here and gets older as it moves in these directions. Magma's coming up, cooling and solidifying here. And this will be shown again on the next slide. So on this constructive ocean to ocean, we've got the plate dividing, magma comes up, cools down here, creates that ridge, and something like 2 to 3 kilometers in height under the ocean. So as it spreads apart, and you can see the magma upwells here. The crust that forms here is relatively weak, and also we do get transform fault lines, which we'll show later on as well. So, and the earthquakes that form here, they do get earthquakes here, but they don't tend to be too strong because the crust itself isn't particularly strong, relatively speaking. But you can see this big macro feature here rises up. There are other things which I'll show you in the subsequent slides. And this is just a static picture. Again, you can see the ridge, magma coming up. Effectively, there's the convection cell moving there and there. Magma comes up, creates this ridge, and we get this ridge push theory kicking in here. But along here, apart from the ridge, we also get things like, I say, these transform fault lines, which are at right angles. And we also get undersea mountains, we get undersea volcanoes, and occasionally when the volcanoes are up long enough, they emerge out of the sea, forming these islands. Classic in and around the Icelandic islands would be a good example of that. Here's an actual example. So here's the Mid-Atlantic ridge, and as I said a few minutes earlier, Arctic, moving towards the Antarctic, and you see this grey area here. It's not just a thin line. You also notice it's not a straight line. So the rate of movement, there is some differential movement, differential consistency in the plate. So it's like, you tear a piece of tissue, it tears at different points. So that's why we get these right angle fault lines, which I'll show you a little bit later on. But this is an actual example, 60,000 square kilometers of undersea mountains. Right, that's immense. By the way, this is the Eurasian plate, this bit here, and the North American plate. So the UK is moving further away from the east coast of the United States every year, roughly about 5 centimeters. Now, looking a bit more specifically, you can see undersea mountains, which would have been volcanoes at one point. There's one like a computer simulations based some data showing that there's an eruption. Whole range of types of volcanoes, fissure eruption, shield volcanoes, and more, and the sorts of lava that's produced. That's for a later part of the unit. We don't need to get too obsessed with the huge variety. Here's Iceland. That side there is the Eurasian plate. That side there is the North American plate. So it's a tourist site. It's on my bucket list to go there, and you can see it. And you can see you're not going to fall into some fiery vat of lava as you do so. Looking at Iceland, these little triangles here represent volcanoes. It's a bit more complex, the geography here, than just being constructive margin. It's also a hot spot, which complicates matters, but also makes it really fascinating. Now, again, this is what I was talking about. Plate moving that way, plate moving that way. It's not a straight line. And you can see there's differential movements. That's got to be down to things like the consistency of the rock, it not necessarily being completely uniform heating underneath here. So there's different speeds, different movements, different densities. So you get these fault lines, they're at right angle. If I were to draw a straight line, that would be at right angle. And tensional force builds up along these points, but never so much that they get high magnitude earthquakes. I'm not saying it's impossible, but it's less likely. Again, just a kind of final view at this particular one. So just to remind you, we get the big feature, which is the ridge. This is not to scale, by the way. There would be sea here. Some magma, as I say, breaks through the crust because it's weak, erupts on the sea floor, like rips in the ground, like fissure eruptions, undersea volcanoes in the more traditional sense. They would be called shield volcanoes. Some of them erupt long enough to form islands. We also have the transform fault lines, which are at right angles. So we have a combination. You're expected to know those things. Now on the next slide, a bit like before, I've condensed some information, which I won't read through all of it. You can just pause the video, look at the PowerPoint slide and grab that information. So just for the video bit, I just want to give you the general essence of what's taking place. So within this, you can see there are specific names of places, rates of movement, but it reiterates many of the things I've just talked about. On this slide, I've got some specifics about the Mid-Atlantic Ridge. That should say 60,000 square kilometers, right? And going from the west to the east side, so where the mountains start and stop, undersea mountains, it's 4,000 kilometers wide. So it's a massive zone. Okay. This one is if you're particularly interested. This is just talking about different sorts of ocean to ocean divergence in different parts of the world. And again, I'm not going to talk about that in any sort of particular depth. So have a read of that. Now, this one isn't done so well, I would say, by possibly even teachers as well. We don't usually teach this down in the lower years, Key Stage 3, Key Stage 4, certainly not needed at Key Stage 4. A little bit more complex, a little bit more violent. I would say that any volcano is dangerous, but I would say the volcanoes at the constructive margin are calmer. You fall into one, it's not a good thing, right? So let's not kid ourselves. But here we tend to get a little bit more explosive, a little bit more extreme, but also some quite spectacular landscapes. There's one in particular, but let's just focus here. So we're still talking about divergence. We're talking about continental plates separating. Again, still moving apart, still driven by a convection cell, but we're not talking about under the ocean. The nature of the plate is different, it's different composition, so it creates different landforms. So there are several examples. The one that I pretty much focus on is the East African Rift Valley, but just to, Rhine, that's obviously Europe, that's the United States of America. Eventually they say, and particularly with the East African Rift Valley, not in our lifetime, but you can see how it would lead to potentially the development of a new ocean. Yeah, that's Africa, and you'll see in a minute. Okay, rifting means almost like ripping away. So rift is like a break. Here's the example. You'll see some photographs soon. So East Africa is pulling away from the main part of Africa. So once that becomes wide enough and exposed enough, you'll see the ocean start to make its way there. And suggestion is this could be way over here at some point. There'd be a new ocean. This is the East African Rift Valley, and again, just a few more specifics. In this slide, we see the basics of it, and on the few slides further, there's much more depth. But I think we need to grab hold of the basics. So we've got the convection cell moving the two plates apart. This part of the plate here, first of all, thins. So if you think like, if you pull a bit of, I suppose, plasticine, blue tack, that type sort of thing, even chewing gum, as you pull it, it becomes thinner and kind of sags down the middle if you pull it carefully and thins. So what happens first of all is that the cross move apart, that section thins, and then eventually this is in combination, magma underneath them can mix and break through and form these volcanoes. That is a rhyolitic volcano. That's particularly dangerous, very high magnitude. And you'll see this later on, you don't see this simple flatness that you're getting here. We get like blocks. And again, I'll show you that. But let's have a look at some actual photographs from the area. So the Rift Valley, part of tourism, I would say. So when we come onto this bit here, we can see as that plate moves apart, what happens is that bit that thins, it tends to go blocky. You don't need to learn words like Orson-Grabens and things like that, but bits stick up, bits drop. As you move the blocks apart, there's subsidence, and you can see this in the picture below. And all the time this is thinning, then eventually magma from below can mix and eventually break through. So a little bit more detail here. Again, there's the picture there. We can see the plate moving that way, that way. We get that blocky-like nature. And again, that'll be a bit clearer in the next picture. As I said, they've got the convection cell. You can see almost looks like a blob of magma coming up. And eventually that will work its way through and there'll be a mixing zone. And eventually some of it breaks through. So again, have a read of that. So I suppose this accurately, which shows more of a representation of what's taking place. So there's the thickness of the crust. You can see it's thinned. There's that chewing gum blue tack analogy. And you can see initially what happens is it thins. And you've got that blocky sort of parts that stick up, parts that drop down, that's creating faulting. And you can see the magma working its way up, doing its job. And if we look at it a little bit more in sequence, the divergence is moving that way and that way. Those bits will drop down, magma comes up, There we go. And you can see, I mean, it's not step like this, but you have to draw the line somewhere. And in the next picture, you'll start to see a little bit more mixing going on here. Breaks through, magma chamber created, eventually, whether it be an earthquake or just the sheer volume or combination of the magma plus an earthquake, for example, and it breaks through, erupts on the surface of these very, very powerful volcanoes. Moving forwards, in this picture, you can see there's water has been collected. Could have run off the sides. It could be that there's a river that's run into that area. In this instance, we're saying it's gone below sea level. There would have to be some flow of water, so maybe the water has broken through on part of the land, where because it's below sea level has managed to flood that area. And really, in a way, this is the start of a new ocean. Now, what I suggest, and this will be in the booklet, is having watched that video, without necessarily re-watching it, just that word blurt. Just write down what you can remember ocean to oceans. Can you get 5, 10 things? So that might be like name of location, key processes, the features, the landforms, those sorts of things. And you just like dump these words down here and here as a recall activity. Recall is so important, where you retrieve information to embed it in your mind. Then you can go back and check. Then on the next slide, this is what I want you to do with all your plate boundaries. So here's a template. Again, this will be provided for you. And what you do is you put the name of the plate boundary. So you go ocean to ocean. You might say Mid-Atlantic Ridge. Here you make a list of the key words and landforms. That's up to you. You can change the size of these boxes. Over here, I draw a labeled, annotated labeled diagram. And then here, imagining I was doing a 4 marker, maybe with some extra some notes in here, I would explain how that plate boundary is formed, creates the landforms that you need. Then you've got a ready-to-go explanation to learn and then apply in the right context. And then you do the same thing for the rift zone, where the 2 continental plates move apart. I've also included, here's an extra slide. It's got some video clips and things like that. This is only to do with ocean to ocean. So this is the first start. Next lesson, I look at destructive margins. And again, there's 2 for that. They're part of the convergent boundaries where they come together. So next lesson is destructive 2 types. Then I'll go on to another type of convergent boundary called a collision zone. That's not mentioned, but I do think you need to know it. Then we'll go on to the conservative boundaries, the hotspots, and that section is then complete. So those lessons to come. Thank you very much for listening. I'll see you next lesson.